Hello again, everybody. Part 4, last section of this particular set of notes for assignment 20 for ABS, aka simplex method. Let's get right into it. First few steps, you already know what's going on by this point. We need an E system, we need a simplex tableau, and we need to find the pivot. So I'm not going to spend too much time on all of that. In fact, here's everything right now. Alrighty, so here is the E system. Here is the simplex tableau. Again, the slack variable 1 equation first, the slack variable 2 equation next, the objective function last. But we have something weird going on here. There's a tie for the most negative number. So you can just choose your favorite or choose whichever one you wrote better or uglier, whatever. It doesn't matter. You get to pick. So I picked the first negative one and then found my pivot column, did some dividing, and this was my pivot. Now this is the first time that a pivot has not been equal to 1. So what you will have to do here is you will have to divide the entire row by this number in order for it to be 1. So let's take a look here. That would be S sub 2 divided by 4 will be the new S sub 2. So when you go through and divide that entire row by 4, you'll get 1 half, 1, 1 half, 0, 1/4, 0, and 4. And this is where most students lose their minds because not only do they not like matrices and row operations, but now you're telling me there are going to be fractions thrown in the mix? And I promise you, this is just, yes, you're just going to have to get used to it. And there's really nothing to be scared of. Trust yourself and you will be fine. So let me move this up right about there. And I will rewrite this matrix with a new S2 in its place. From there, we will have to go into row operations to make sure that we get zeros above and below this 1. So what would those row operations look like? Well, it becomes pretty simple. I mean, all we have to do is multiply 1 by the opposite of these values here, and then we can go into adding the rest of those rows, and let's just see what happens. All right, so I have the row operations listed out over here and then color-coded to be with the actual row operations here. And you'll notice that if you go through and you sum up the elements of the first equation in red, you'll see that the first row totals to 0. The next row is -1 plus 1 half. That'll end up giving you a negative half. Luckily, the rest of this row is easy to figure. 0 plus 0 is 0, 1/4 plus 0 is 1/4, 0 plus 1 is 1, and 4 plus 0 is 4. And that is the new P. Similarly, over here, we can add up the rows. This would be 0, 5, 1, -1 half, 0, and 10. And that is the new S sub 1. So we would rewrite the matrix to be replacing these current rows for S1 and P with this new row for S1 and P. And that will look like, oh no, I'm gonna run out of space. All right, so here's this new matrix. And again, you can see, well, you can't see, but the original column that looked like 0, 1, 0 was underneath S sub 2. Now it is underneath X sub 1. So S sub 2 exited and X sub 1 entered the variables here. And this is very interesting because you can see that the last row now, for the first time again here, has a negative still left in it. So we need to keep repeating this process until all of the negatives are gone from this particular row. So we have to repeat this process of finding a pivot column, which will be here. This is the most negative number. This is the only negative number we have left. Then we have to go off to the right here and divide the last element by the element in that column. So this would be 4 divided by 1/2. And that actually ends up being 8. And 10 divided by 5 is 2. So you still want to pick the smaller value. In this case, the 2, which means the pivot position is the 5 here. So that means you have to now divide s sub 1 by 5 and use that to replace s sub 1. And this ends up being really fun. Repeat after me. This is going to be really fun. And I will do the math for this row operation right here. And then I will replace this row on the next slide. So here is the new row for s sub 1 when you divide by 5. Another way to think of this is you multiply the denominator by 5, and then you can simplify if you need to. So dividing 0 by 5 is 0, dividing 5 by 5 is 1, dividing 1 by 5 is 1 over 5, and this is where I think about multiplying the denominator by 5. The denominator 2 here multiplied by 5 is a 10 in the denominator, so it's -1 still in the numerator, 10 in the denominator. 0 divided by 5 is 0, and 10 divided by 5 is 2, which is what we figured out very early on. So on the next slide, this will be the new row 1, and we will start with some newer row operations. So here is that new matrix with this row replaced with the row that you saw on the last slide. So now that the 1 is here, we need to make sure we get zeros underneath this 1, which again will require 2 different row operations. The first one will be, let's see, -1/2 s sub 1 plus x sub 1, and we will replace x sub 1. And the other row operation will be 1/2 s sub 1 plus p, and that will replace row p. So I'm going to give you a chance to figure these row operations out. Again, repeat after me. These row operations are fun. So go ahead, try to figure out these row operations. I'll be back in 5 seconds with the answers. Here are your row operations for these two, or at least all the work behind the row operations for these. Now I'm pretty sure with what I explained in the last slide, if you're dividing by 2, right, multiplying by 1/2, you can see is a division by 2. You can either multiply whole numbers like this, or you can think like you're multiplying a denominator by 2. So 5 times 2 is 10. That's why the 10 is down here. 10 times 2 is 20. That's why the 20 is down here. The only other thing that I think I need to explain here is this addition. In order to add fractions, you have to have a common denominator. So when I see 1/20 and 1/4, I know the common denominator will have to be 20. So 1/20 plus 1/4. In order to make this a 20, I would have to multiply the top and bottom here by 5. So this would be 1/20 plus 5/20, and now that they have a common denominator, I can add the numerators together to get 6/20, and then it can reduce that by dividing the top and the bottom by 2 to give you 3/10. And something very similar happens over here. So with this new matrix now, we have the following. And you can see that the variable changed from s sub 1, where we had the 1, 0, 0 to begin with, to x sub 2, which is where the 1, 0, 0 is now. So how do you read off your answer? Well, we have an x sub 2, we have an x sub 1, and we have a p, which was our objective function. So it looks like our solution here would be something like this. X sub 1 is 3, x sub 2 is 2, and p is 5. So we have a maximum of 5 when x sub 1 is 3 and x sub 2 is 2. The other way of writing that would be, let's say in words, would be you have a max of 5 at 3 comma 2. Right, and so again, if you think of x sub 1 as the x variable and x sub 2 as the y variable, we can put them in an ordered pair like this. And I guarantee if you went back and you looked at all of the inequalities that we had, and you graphed those on a coordinate plane, 3 comma 2 would be one of your corner points, and that would probably be the corner point of the feasible region that would give you the maximum. I've got one more example for this video, so let's get to it. All right, on this last slide here, we have an example that says maximize this objective function to these constraints. So again, I'm going to give you a chance to set up the E system, set up the simplex tableau, and find the first pivot position. Pause the video, try that now. So I clearly went a little further than I asked you to do. And that's because I think the next couple steps were pretty simple. So let's review. The first inequality here, we would add slack 1 and set it equal to 20. The second inequality here, we would add slack 2 and set it equal to 12. And again, in the first equation here, the optimization equation, the objective function, the maximizing equation, we need to make sure that the p stays positive. So we subtract 20x sub 1 and 5x sub 2 from both sides, and that will equal 0. So this is the last equation we need in our simplex tableau. That being said, negative 20 is the most negative number here. And when you divide the last element in each row by the element in this column, you get 20 divided by 2 is 10, and 12 divided by 1 is 12. So we pick the smaller one, 10. There's the pivot position. You know you need a 1 in this pivot position, and this starts getting into what I went past asking you to do. We need a 1 in this pivot position, so we would divide everything in this row by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. 1 divided by 2 is 1/2. 0, 0, 10, 20 divided by 2 is 10. So I replaced that top row with this new S1. From there, we can certainly multiply S1 times negative 1. So let's do that. Negative S sub 1 plus S sub 2 will be the new S sub 2. And lastly, we have 20 S sub 1 plus P will be the new P. So again here, pause the video, try that for yourself, and I'll be back in about 8 seconds with the new matrix. Alrighty, here is the new matrix. Did you get this too? I hope so. So here comes an explanation for this new matrix. The first row operation you see here, negative S1 plus S2 will replace S2, looks like this. So negative, we'll apply a negative or change the signs of all these numbers here. And I realized I made a mistake. This should be a negative 10, and this answer should be 2. So if you think you're making a mistake, you might want to check it out. Explaining it to somebody should surely help you find your mistakes. So That is there. This should be 2, which means this down here should also be 2. Cool. All right. And for the second row operation, we have to multiply S1 by 20 and then add it to row P, and that new row will replace the old row P. So 20 times everything here, this would be 20 times 1 is 20, as you can see. 20 times 2 is 40. 20 times 1/2 is 10. 0, 0, and 200 is 20 times 10. And I think that's it. I think we are done. If you look at the bottom row here, let's get a highlighter, there we go. You look at this bottom row, not a single number is negative. So what that means is we're done. We can list off our answer. Oh, but we don't have any labels over here. And that is important. So remember, the original 100 is underneath S1, so that means S1 now changes to X sub 1, sub 2, and P. So the final answer here, again, we only are worried about the actual X variables here. And here we have the objective function being maximized. So we know we can have the max of 200 at, let's see, x sub 1 is 10 and x sub 2 is 0. We don't have a value for x sub 2, and if you don't have a value, if something doesn't have a value, then it is 0. So that's it. That's the end of this lesson. I hope this is starting to make more sense for you. If not, and you're lucky enough to be in one of my classes, feel free to ask questions in class. Otherwise, I'll see you in the next video. Good luck, everyone.